Hi everyone, welcome back. Today we're doing group anagrams in C++. For this question, we're given an array of strings and we have to group the anagrams together and we can return the answer in any order. So for our parrots over here, if you would like to try this out, I would highly recommend doing valid anagrams first before doing this. So an anagram is a word or phrase formed by rearranging letters of a given word or phrase, typically using all of the original letter once. So in the previous challenge, we saw anagram and how we can rearrange this to get a separate string like this, where both strings have the same number of characters along with their counts. So in this case, we have a vector like this, and we are supposed to go through this list and group them together such that all the anagrams are in the same list. One thing that you might notice is the final output would have the same number of elements as the input over here. So in this case, bat is not an anagram with other words. Nat and tan are anagrams, so they are in the same vector, and 8, eat, and tea are also in the same vector because they are anagrams. So if we are given strings like this, like an empty string, then the empty string would just be grouped together. And if the list only contains A, then that will be all we have. So for this vector of strings, we'll have at least one item until 10 to the power of 4. And for strings over here, every single item in strings, they can be 0 characters or 100 characters, up to 100 characters. And every single string consists of only lowercase English letters. So a naive approach to go about this would be to take every single word and compare with the others to check whether if they're anagrams with them. And if they are, then put them together in the same vector. But this would be very inefficient because if we want to check two strings to be anagrams, we would have to iterate through both strings in the worst case if they have the same length. So that's going to be on for one check. And if you end up checking it with all other words in input, this is going to be on square for processing this input over here. So that's not very efficient. So the smart parrots will probably be thinking, is there a better way? And it happens that there is a better way. One way would be to take in each of these strings and we will sort them. And if the sorted strings happens to be equal to each other, then we would just group them together. So that's pretty much it. And the idea is we'll be using a hash map to keep track of these sorted strings. And the key will be the sorted anagram and the value will be the vector of strings. So this way we are able to easily put all of the anagrams together inside the hash map in O1 time. The drawback of this approach is that we will have to sort the strings. So now the strings would be, the length of the strings would be our bottleneck over here. So let's get started with this approach. The first step would be to import the unordered map. And the next thing would be to define a method to sort the string. So let's call this string reference, and let's sort string, and this would take in a string reference as well. So this would be, actually we can just do this, input string, and what this method will do is to sort this alphabetically. So std sort input string begin, input string end, and that's pretty much it. So this is a static void method. Okay, that's pretty much it. So solution dot sort string for, okay, let's first define the unordered map. So unordered map, this would be another map of sorted strings to vectors of strings, and let's call these sorted string to anagrams. So for each of these string inside strings, we will sort the string. So we would just sorted string equals to, actually should we just return, yeah, let's just create a copy of this input string. So called sorted string equals to input string, and okay, and so now we have this input string, then we can sort this string and return back the sorted string. Let's call this okay, actually we don't have to, yeah, let's just call this sort string and let's pass in the current string, and now we have a sorted string. And once done, we can set this sorted string, push back current string, and that's pretty much it. We are sorting the string to get the key, and we will use the key to add this current string into the anagram, and that's pretty much it. So now that we have this, the next step would be to iterate through every single item inside this unordered map over here. So for okay, how do we iterate an unordered map in C++? So let's see. I guess we can just use the auto key value in sorted string to anagram. This represents a pair. So in this case, the vector of strings would be equals to key value dot second, and that's all we really need. So we will define a vector of a vector. Sorry, actually this is just a vector of a vector of strings, and we'll call this the answer, and we will do answer dot push back, okay, current vector anagrams, and we can return back the answer like this, and that's pretty much it. Let's use this example to understand this one. So let's use this, yeah, let's just use this example. So the current string over here is eat. So if we sort it, we would get AET, and we will use this AET to store it inside this sorted string to anagram. So sorted string to anagram will be equals to AET, and we will have a vector, and we will push this eat here. Let's move on to the next item, which is t, and if we sort it, we get AET as well, and we would put t inside here. Now we will move on to 10. So 10 would be A B C D E F G H I J K L M N O P Q R S A N T. So ent would be the sorted string, and we would add ent to contain 10 over here. Let's move on to ATE. So this would be AET, and we would put 10 inside here as well. So we have processed forwards thus far. Let's move on to net. So this will get ANT as well. So we'll add net here. And for the final string, this is bet. Bet sorted will be ABT, and we'll add ABT to contain bet. And we will have the sorted string like this. So over here, we would have the key value. We will iterate through the key value pairs inside the unordered maps. So over here we have AET, and we have a pair. You can think of this as a pair like this, and we have AET followed by all of the anagrams here. So we add AET and EAT into the answer. So answer would be looking like this now. The next pair is ANT, and we have 10 net and 10 and net, and we will add it here. And finally we have BAT, so BAT. So there we go. And we would add BAT into this answer as well, and we should get something like this. So at this point of time, I'm pretty confident that this works, but I'm not too sure about my syntax. To be specific, I'm not sure if this is how we create a static method in static methods in C++ classes. Let's see. So okay, they have a static how do you define a static function method here? Okay, so static in get count, and how will you call get count inside your class over here? Okay, so they're calling it outside of the class. So my assumption is that you should be able to call the method just by doing sort string like this. So that's my assumption, but let's validate my assumption by running this against some sample cases. So looks like it's judging. Oh, it works. So this validates my hypothesis that if you have a static method like this, you can just call it like this without having to do something like this. I was suspecting we might have to do something like this, but let's just try this as well and see if we are able to run a static method like this. So looks like this works. Let's run this test case, and there we go, this works. So the time complexity, if we let n to be the length of strs containing strs, then we are going to iterate through all of them here. For each of these strings, like they have a length as well, and we are doing a sort. So let's let m to be the longest string in strs. So for every single ON over here, we are going to sort it. So this is going to be m, log base 2m, since we are going to sort it. But since the strings are up to 100 characters, I mean, you can think of it as a small little constant value. So if you want to simplify this, you can pretty much just call this O1, m is small, up to 100 characters. So let's simplify this and just make this O1. So this will be ON, and pushing it to this hash map will be efficient as well. Now, for iterating through the anagrams over here, in the worst case scenario, this would be iterating through all keys such that every single key is a unique key. And this worst case happens when all items inside strs are not anagrams of each other. So that would be ON over here again. So worst case is when happens when all values in strs are unique anagrams. So we will end up having a full ON iteration here as well. But in summary, the time complexity is ON because we have ON here and another ON over here. For the space complexity, we will store all values inside these sorted strings to anagrams. So this is going to take ON at least. And we are also going to store the values into this answer here as well. So this is going to be another ON space over here. So this is going to be O2N, but if we remove the coefficients, it's going to be ON as well. And that's pretty much it for this question. My personal reflections, I needed a refresher on defining static methods in a class and how do we call this static method inside classes. So to recap, we can call it like this, where we separate the class and the method with these double colons. Or in this case, since we are calling the method inside the class, we can just remove that, and C++ will be smart to know that we are calling sort strings here. So by the way, I wasn't too clear here, but what we're doing here is we are copying the string from this string reference. So like we are copying it and we are putting it into a new string, and we are sorting this sorted string over here, and we are returning the sorted string. Another question that you might have is it really necessary to have this string to be an L value, or I mean for this to be an R value where you do not have a reference to this string? In this case, it's not necessary. You can remove that. So hopefully this is clear, and that's pretty much it for this question. So I confused the L and the R value over here. But to our viewers, R values is a value that doesn't have any locator, doesn't have any memory reference. So let's say int my value equals to 10. In this case, the 10 over here, this 10 value over here is not really inside a memory reference yet, and we are assigning this 10 into my value. So my value in this case is like a memory reference containing an integer. So my value over here would be an L value where it has a location, a memory location. And for this 10 over here on the right hand side, it's not assigned to a value yet. So at this point of time, it's still an R value. So if you have to pass in if you have a function signature like this means that you can just pass in a string like this, or you can pass in a string my value equals to 1, 2, 3, and you can call sort string on both 1, 2, 3 or sort string on my value. So sort string, static string, sort string, string, input string. This would accept both inputs over here. But if you are to have a sort string that requires a memory reference like this, then you can't do this. You would have to pass in a variable that contains a string over here. So to validate this hypothesis, I'm going to purposely crash this by passing in 1, 2, 3 like this, and this should crash because 1, 2, 3 is currently an R value. It doesn't have a location yet, so this should raise a it didn't raise a compiler error. Or is it because that this string was defined in memory? Okay, let me just I guess for this example, I'm guessing when we define a string, it seems that C++ assigns memory to that string. So it's taken as a L value. But what if we have okay, I'm going to create a dummy method. Let's call this static int accept our value. So this is going to be an int, input int, and I'm just going to return the input in like this. So this should accept only, this accepts R values like 10. So if I do accept R value and pass in a 10, this should work. So this should not raise oh sorry, I missed out a colon over here. So let's run this. Yep, this works. But if you change this to if you create a separate method here, and let's call this accept L value, and you need a reference like this, and you call this, this should fail. This method requires a variable memory reference to of a variable storing an int. So we pass in 10 here. This int is not stored in memory yet. So this should fail. We should have yep, exactly. So non-const L value reference to int cannot bind to a temporary type of int. So if you have a int value here and you assign it to 10, then this will work. Okay, this is off tangent, but this is just to explain why I use the n% here. But it seems that for strings, it seems to work. So if you take in a string, set, let's comment this out and use strings instead. It seems that for strings, they are taken as objects. So when you define an object, it exists in the heap. So every single string object has a r and r value, like 1, 2, 3, or string input value 1, 2, 3. So for strings, this is an exception. So let's validate our hypothesis over here. Let's pass in 1, 2, 3, and also a dummy string, input string equals to 1, 2, 3, and let's pass in this input string as well. So yeah, this is just to validate our hypothesis that this works for strings, because strings are objects under the hood. So this will work. Yep, this validates our hypothesis. So we went a little off tangent and talked a little bit about L values and R values, but hopefully this was useful. So yeah, and that's pretty much it for this question. If you love this series, we will hope to see you in the next one. So with that, have a good day and see you in the next video.